This video will walk you through a smart residential installation. In today's example, we'll install smart modules and a Fronius IG Plus smart inverter. Smart modules are solar panels manufactured with power optimizers embedded within the junction box. These new ease-of-use features from Tigo enable module-level optimization and monitoring without scanning any barcodes. A smart inverter is one with Tigo Cloud Connect technology inside. It manages your optimized power production and sends module-level data to the Tigo servers. The installation begins on the roof by laying out the PV arrays and installing the racking and modules. As you connect each PV module together in series, positive to negative, be sure to manage your wires. Once you complete a PV string, identify the positive and negative ends to be connected later. Then, if you've not already done so, create DC jumper and home run cables as needed. When crimping the MC4 connectors on the DC conductors, be sure to crimp the connectors according to the correct polarity, positive or negative. The DC jumper cables can be used to bring the positive or negative DC ends back to the DC junction boxes, or link panels together in the same string. Run home run cables from the inverter to the DC junction boxes and crimp the correct MC4 connectors to connect the PV strings. Caution: do not connect the home run cables to the PV strings until the electrician is ready. At this point, test the voltage of each PV string with an appropriate DC voltage meter. Ensure the total voltage measured equals the expected open circuit voltage of each string. If the string does not match the expected total, double-check each connection in the string. Meanwhile, the solar inverter should be affixed to a wall in close proximity to the building's AC meter and according to the inverter manufacturer instructions. Regardless of the smart inverter type, each one will be pre-wired with the Tigo gateway. If the PV array is more than 30 feet from the inverter, you'll need to relocate the gateway to the middle of the array and install a new and longer RS485 cable between the gateway and the smart inverter. Next, wire the AC side of the inverter according to the manufacturer's instructions. Ensure the DC connectors of the home run cables are not energized, and then terminate the DC conductors at the inverter. Be sure to terminate the wires according to the correct polarity, positive or negative. After the inverter is properly installed, the electrician can make the final DC home run connections for each PV string on the roof. At this point, test the voltage of the PV string at the inverter. Just like on the roof, ensure that the total voltage measured equals the expected open circuit voltage of each string. If the voltage does not match, double-check any connections on that string. Finally, make sure to go over the inverter commissioning steps outlined by the manufacturer. This includes connecting the inverter to the internet before turning on the AC or DC switches for the inverter. The Tigo smartphone app will walk you through the final commissioning process of your PV system and establish communication between the panels and the inverter. The app is available for both Apple and Android phones. Use the app to configure the inverter's internet connection, either Wi-Fi or wired Ethernet, and test the network connection status. During this process, maintain consistent AC power to the inverter until the app has found all the panels. With the commissioning process complete, your solar system will immediately begin generating clean, renewable energy for your customers.